Hi everyone, welcome back to Geeks for Geeks. In this video, we'll discuss the problem distinct occurrences. Previously, this problem has been asked in Amazon and Google. So let us see what the problem statement says and then we'll try to solve this problem. So in this problem, you will be given two strings. One string is named as S and another string is named as T. The length of the first string will be N and the length of the second string T would be M. It says that you have to find the count of distinct occurrences of the string T in the string S as a subsequence. So if you will see the string S, let's say string S is written as BANANA. Okay, so this is the string S that we have, and then the string T is what? The string T is BAN. Now if you see, how many times can you find the subsequence BAN? Right. So firstly, you can see that if I take these three characters together, right, that is one time when I can find subsequence BAN. Another could have been that if I take a different color, and what I will highlight here is if you take this B, okay, and you take this AN, right, then also you could have done it. Right, so these are the two times that I can highlight. Now after that, apart from this, what I could have done is if I take another color and I take BA from here and I take this particular N, then also this is one more different time than I could have done it. Right, so there are three times that I can find subsequences, because what I can do is I can choose BAN directly, or I can choose BNA and then I can choose N later on. And also one more thing, what I can do is I can choose B in the very starting and I can choose AN as well. So these are the three occurrences when you can have, right? So you can either have BAN or you can have BA, like here this blue BA, and then you can choose N later on, or what you can do is you can choose B right now and then AN later on. So basically these are the various subsequences that you can make. So total of 3 subsequence for this string, right? So what are the circumstances, right? If you will observe, it is very clear that if suppose what happens is if I am at a particular character, right? So let's suppose I will be a character in the string S and J will be a character in the string T. Okay, so if they are same, suppose that what is the scenario when I will say that I have found the subsequence T? Suppose that if ith and jth character are same, so I might do what? I might say that okay, they are same, so they can be considered as same, and then I'll move in both by one step for the next character. So I'll do I plus 1 and j plus 1. As I keep on doing j plus 1, so at one point of time I will reach the end of the second string, that is T, that is for BAN, we will reach the end. Whenever we reach the end of the string T, then at all those instances I'll be counting 1, because those will be the scenarios when I'll be able to generate the subsequence, because I must have got a B, I must have got a I must have got a N, right? That is how I must have reached the end. So the number of times that I reach BAN, I iterate, I end the traversal in BAN, that is the number of subsequences that would be there. Okay, so there are two choices. Either if I am at a ith character and I am at a jth character of the second string, so if the ith character suppose is not the same as the jth character of the T string, okay, if the ith character of the string S is not the same as the jth character of the string T, then I do not have any choice and I have to move away from the ith character of the first string, because I want to match the jth character at any cost, right, of the second string. Otherwise, if they are same, then I have a choice. Either I take it, okay, so either I match it, I take it and I do I plus 1, j plus 1, or I don't take it, right? So it is like this. If the ith character of the first string is not the same as the jth character of the second string, if they are not same, then I will do what? Then I will have to move forward in the first string and I still have to find a match for the jth character of the second string, right? If they are not the same. Otherwise, if they are not same, this will be the scenario. Else when they are same, so I have got two choices. Either what I can do is either I can say that I will match them up and I'll say that the ith character and jth character matches, so I'll call the recursion for I plus 1, j plus 1, right? So I'll move forward in both the strings considering that ith and jth character are same, right? Otherwise, what I will do is I can say that I will not match that. Even if it is matching, I'll not match that particular jth character, and I'll say that I'll still stay at this jth character, I'll try to move my I forward, because what I will do is, if you see, suppose B and B are matching, so maybe I can say that this and this are matching. I'll say okay, fine, then A is there, so then I'm at this A. So suppose like one time I will say that I will match it, another time I'll say I'll not match it. Why? Because another time I will match the A of the string T with this particular A that I'm highlighting right now with the red color. Okay, so that is why we have to consider that when it is the same, then there are two instances. When it is the same, then either I can do what? Either I can mark it as the same, I plus 1, j plus 1. I can move forward in both the strings, considering that the jth character of the second string has been matched. Or I can say that the jth character, I will wait and I'll say that I will look for a further index in the first string and I'll try to match it later on. I'll do I plus 1 comma j. If my j reaches equal to m, or if you can say that my j reaches the end of the second string, in that case I can say that yes, we have achieved the scenario when the second string has been traversed completely and all the characters I was able to match, and in that case I will return 1. So this is what we need to do. So this will be a recursive approach in nature, and we need to optimize it using the dynamic programming as well. So let us try and implement the code for it. I hope that you have understood take or not take circumstances. Whenever you have to consider subsequence or all possible circumstances, then we consider recursion. Okay, so let's try and write the code for it as well. So what we'll do here is, firstly I'll say that int n is equal to s dot size, so we'll get the size of the first string. Then I'll also say that int m is equal to t dot size, so I'll get the size of the second string. Then after that, what I will do is I'll call the recursion. Initially I'll start from where? I'll start from the 0th character of both the strings, so I'll start from 0, 0. Okay, and then I'll pass the string s, I'll pass the string t, then I'll pass n, then I'll pass m as well. Okay, this is what I'm going to pass. Now what will happen here is I need to call this int recursive function. Okay, and eventually it would do what for me? It would return me the total number of subsequences that I can make of the string t from the string s. Okay, so I'll be at the ith index of the first string, at the jth index of the second string, then I'll pass a string ampersand s, the first string, and then I'll pass a string ampersand t, the second string, and then after that I will pass int n, I'll pass int m as well. The n and m where n is the length of the first string, m is the length of the second string. Now the moment it happens that, like, let's say if j is equal to m, so if you reach the end of the second string, what does that mean? This means that you will return 1. If you reach the end of the second string, this means that it is one of the opportunities to make a subsequence, because you must have matched b, a, and then n, and that is why your j must have reached the end of the second string. If you reach the end of the second string, sorry if I said the first string, but if you reach the end of the second string, this means that you were able to match each and every character, and that's why you will say that one subsequence you will be counting, so you will be returning 1 as a counter. Otherwise, if you are not able to do so, and at one point of time it might happen that you might exhaust the first string. If you exhaust the first string without reaching the end of the second string, in that case you should return 0, because that would not be possible any further, right? Because the first string is exhausted. Otherwise, suppose that s of I is not equal to t of I. So if the ith character of the first string is not the same as the jth character of the second string, if it is not the same, then you have only one choice that you can say is answer will be, you'll call the recursion for I plus 1 comma j. You will still try to match this jth character for the second string. You'll pass j, s, then t, and then n, and then m. Okay, this is what you're going to do. Let me declare initially an answer variable here as 0, right? Otherwise, if they do match, okay, if the ith character of the first string is the same as the jth character of the second string, in that case you have two choices. Either you take, right, so if you take the ith and the jth character as the same, then you'll move forward in both the strings. So you'll do I plus 1, j plus 1, then you'll pass a string s, you'll pass string t, you'll pass a string n and m, right? Otherwise, if you don't take, so if you skip this ith character matching, right, so then you will say that you will move forward to the I plus 1th character. You will try to see if there is any other character in the first string that matches the jth character, okay, and you will pass s comma t comma n comma m here. And after this, since you want what you want, the total number of ways in which your subsequence would be there, so you will say that it will be nothing but the sum of the choice of take and not take, that is take or skip. And obviously I have to do a modulo with 10 to the power 9 plus 7, so I'll declare a int mod is equal to 1e9 plus 7 here. Okay, now after this, what I will do is I will take the mod here also. So because the calculation might be long, so we have been asked to return the answer after taking the modulo only. So like we have done this, and then let us return this answer. Now once I have returned this answer, so obviously this will give me a TLE. Why it will give me a TLE? Because this is brute force recursive approach and I need to optimize it using the dynamic programming. So it says that something is not declared. So let me see if there is any issue here. Int skip. So I have written int take and int skip. Okay, and I'm calling the functions correctly. So let me see if there is any mistake from my end. So it is expecting a colon. Yes, I have missed a colon here. So let's now try and compile it and check if it is working fine or not. It works fine on the samples, but it will give a TLE because current time complexity is exponential in nature. So let's see if it gives us a TLE or not. Yes, it is giving us a time limit exceeded error. So now we'll optimize it using the dynamic programming approach. So what we will do here is we need to declare a DP of 2D size because two parameters are changing. I is changing and J is changing. So we need a 2D DP here. So what we'll do here is we'll have vector of vector int and let's declare DP. And then after that the size would be n comma vector int m comma -1. So initially I'm initializing my DP to -1. All the states are not calculated initially, so I'll pass the DP here, then I'll pass the DP here as well. So vector of vector int ampersand DP. So in Java or other languages you can also pass your 2D arrays. And let's pass the DP as a parameter in all the other functions as well. So I'm passing it here, I'm passing it here, and I'll pass it here also. Now what I will do is before calculating the answer, I'll check if the DP of ij is not equal to -1. This means that if that state is already calculated, then if it is already calculated, I will directly return it. I'll not calculate a state again. Okay, if it is not already calculated, then what I need to do is I need to calculate it. So once it is calculated, I need to store it so that next time when I come to that state again, then I don't have to calculate it again. I'll calculate it, store it, and then return the answer so that next time I don't have to calculate it again. Let us try and compile this code to check if it is working fine or not. So you can see it is working fine on the samples. Let's try and submit this code to check if it is getting accepted. So you can clearly see that our code was able to pass all the test cases, and since I'm using 2D DP, that is there are two parameters that are changing, so the different number of states can be n cross m, that is the length of the first string into the length of the second string, that is n into m, and the space complexity for my code would also be n into m because I'm using a 2D DP here. If you understood this problem clearly, please make sure to comment understood or +1 in the chat. Thank you for watching this video guys, and keep coding.